Aloha class, homes. It is BC time. I love it. I love it. So what we're going to do, the cool thing with the BC topics is we're going to use things that we learned in AB, and we're just going to take it a step further, okay? So for example, when we deal with something called Euler's method, okay, Euler's method is basically linearization on steroids, okay, class? So just a real brief introduction of what Euler's method is. So way back in the day, if we had some curve, let's say, okay, and let's say we didn't have calculators, so it was difficult to find the instantaneous rate of change at a specific point. Okay, let's say that point right there. Okay, so what did we do instead? Well, we used linearization, right? We found the equation of a tangent line. Now, we learned back in the day when we did linearization that as long as I'm really close to x is equal to a, then it's going to give me a pretty darn good approximation, right, of what the actual red value would be. Okay, and we'll use the blue as our approximated value. Now, the further I get away, the less I'm going to get more of an error, right? So Euler discovered way back in the day what he thought he would do, which thought was pretty cool, is he used slopes, instantaneous rates of change, but then what he did is he would just walk along this line. So let's say he walks to right here. And then what he would do is he would just recalculate. So he would do linearization again. And when he did linearization again, it would be the slope of that point right there. And what he did is he used that point, but he used that guy's slope. So he got, guess what? That line is a little bit closer. The error isn't as great, right, class, from here to here. And then what he did is he'd walk up a little bit more, he'd get a steeper slope, and he would get even a more approximated. So as he went further and further out, he used the new slope of the curve, and thus it gave him a better approximation, and thus less of an error. So how do we use this in BC? Well, here we go. We have this ridiculously cool table that gets it all done for us. Okay, so we have our x, we have our y. That's where we start out with, okay? And then, right, we have our slope. We have our slope of the curve, right, of the original curve. We have what we call our change in y, which you could easily solve for, okay, class, using your slope. And then we have what we call our new y. And we build this table until we get closer and closer to the actual value that we're trying to approximate. And that value that we're trying to approximate, what it is we keep on doing linearization to get a better and a better approximation. So obviously, the closer or the more increments we use, the better the approximation we're going to get. All right, so let's go ahead and see how we do this in AP Calc. All right, so here we go. Example 1. Okay, we're given a differential equation. There it is. Okay, so we have the slope right there for anywhere on that curve. Okay, and then we have an initial starting point as well. So to do, and we are trying to approximate a y of 0.8. And it will even say it on the AP exam. Let's use Euler's method, and let's just use 2 equal steps. Well, 2 equal steps. In order for us to have 2 equal steps, we want to know how big those steps are. Well, if you think about it, they give me an initial x value of 0. So I'm going to call A 0. And we want to get to what? B equals 0.8. So what we want to know is how big are these steps we're taking? And we're going to call that our change in x, right? Because we go from x equals 0 to x equals 0.8. And our change in x formula from here on out is going to be b minus a all over the number of steps. So for this particular problem, it would be 0.8 minus 0 all over 2. So my steps are going to be 0.4 because they're going to be equal steps. And then we're just going to reevaluate when we go. Now, all you have to do to get an answer for this bad boy, believe it or not, is make our table. And our table is x, y. Okay, I'm going to draw a little line like that to keep ourselves very organized. Next is y prime, or m, which is dy dx, right? Those all mean the same thing. I like to just use y prime. It reminds me of this table that we have to do. Our next is our change in our y. Now, how do I find the change in the y? Well, if you look at right here, your change in your y is going to be your slope times dx, right? It's kind of like dy equals. That's just solving for dy over here. And then my last little piece is my y new, my new y. And my new y is going to be your old y, okay? So it's my y plus my change in y, okay? So let's go ahead and do this. Get this started, and we use our initial value, which is 0, 5. How do I find y prime? Well, oh, sweet, it's right there. It just means I put a 0 in for x and a 5 in for y, but there's only an x. So I do a little here. I'll show all my work. So I have my dy dx, or my y prime, which would be equal to 0 minus 2, which would be equal to negative 2, okay? So there's my y prime. Next, I find my delta y. Well, it says here the way I find delta y, or dy, would be your slope, which is negative 2 times my change in x. And my change in x, I got my right there, right? Which would be 0.4. Do a little multiplication. I get negative 0.8, right, class? And then last, I want my new y. Well, how do I find my new y? I use my original y, which was 5, and I add a negative 0.8 to it, and I get 4.2. Now, I have to keep on going until I end up with an x value of what I want to approximate, which would be 0.8. Now, my new x, right, I changed it by, what do we say? Oh, we changed it by 0.4, so it would be 0.4, 0 plus 0.4, which would be 0.4, and my new y would be 4.2. So now what I'm going to do is I'm just going to keep on going, and I have to keep on going until I get an approximation for 0.8, right? That's going to be my next one. It said 2 step sizes. How about it? There's 1, there's 2. I will be done once I'm able to find that. So guess what? I just repeat the process. And what I want you to do right now, I know we haven't done this, hit pause and see if you can get the right answer as I am doing it, okay? But challenge yourself, make sure you hit pause. All right, let's see if you got the right answer. Unpause that bad boy. My next is I find y prime. Y prime would be just this guy right here, would be my x. My x is 0.4. I'm going to subtract 2 from that. Everyone with me? That gives me a negative 1.6. Okay. My delta y, remember, is my slope. My new slope is negative 1.6, right? I'm still going to multiply that by my change in x. My change in x stays consistent at 0.4. Do that multiplication, I get negative 0.64, okay? And then I just have to find my new y. Well, how do I find my new y? Well, it's my y that I'm at right now as I'm taking these steps, which is 4.2, and I'm going to add a negative 0.64 to that, and I'm going to be so impressed if you got this answer on your own, and you should get 3.56. Okay, so I come over here, 3.56, and guess what? I'm done. Why am I done? Because I have that, and they're asking me to approximate it. So y of 0.8 is approximately equal to 3.56. Boo! That is Euler's method. Okay, that's all there is to it. The only way that it gets maybe a little bit tougher, and I shouldn't say tougher, just maybe a little bit more annoying, is when they have you do a lot of steps. Okay, that was just a 2-stepper right there. Okay, guess what? That's the same problem we just did, and this is what comes up on the BC part of the test. Okay, or they might sneak something in there on the AB part, and they'll put Euler's. So we did Euler's method to approximate. Okay, which is better than linearization, right? Because I kind of used 2 lines to get a better approximate. Okay, and then they're going to say, okay, solve a differential equation, which, shoot, we just got done doing this, right, class? So this should be nice and easy, Japanesey, right? So we just go ahead and we separate these guys. You should be okay with this. Actually, you know what? You better be hitting pause and making sure you can do this on your own. Because if you can't, you're in trouble. Okay, antiderivative of both sides, right, class? Plus a C. Ooh, snap, a C came up. So that means I use my initial condition right there, which would be 5 is equal to C. So then I'm going to come back here and rewrite it. Oh, snap, I don't even have to solve anything. Don't even have to worry about initial condition. But booyah, there you go. And then I'm going to find the exact value. How do I find the exact value? I'm going to put a 0.8 in there. This would be a calculator part. I've got it right here. I got 3.72. I'm just going to round to the hundredths because my answer up there was, right? And hopefully you remember that your error, right? Your error for this particular problem, they didn't ask for it, but they usually do on the AP, is your actual minus the approximated, right? So that'd be 3.75 minus, what did we get up there? 3.56. That's kind of a decent error, isn't it, class? 0.19, right? That's kind of a decent error. Once again, we're using lines. That means the curve must take off a little bit there, okay? All right, here we go. Example, is that all they asked me to do? Yes, okay? That's what they asked me to do. Ooh, I think in the top, I may have skipped it, but it asked to sketch a solution. Okay, what would it mean? And then ask that for part A, what to sketch a solution. You just make points. Okay, you got 0, 5, boom. I'm going to go by 0.4s. That's 0.4. That's 0.8. So when I ask me to sketch my solution, right, we'll say that's 0, 5 right there. Okay, 0.4 is, and there you go. That'd be my first line would be that guy right there. Okay, and then as I just go on, right, I'm going to make a new linear approximation. And so that would be, that right there would be 0.4, 4.2. And then this is going to be 0.8, right? It's going to be up here a little bit. So you can kind of take a guess that the original function, the original curve would be somewhat of a parabola, right, class? Which, booyah! How about it? It's exactly what it is. But that would be sketching the solution is drawing all of your lines right there, okay? It's really just connecting the dots. All right, let's keep rolling here. I'll try to keep these videos short because you're going to have to do homework here with these videos at home, okay? You got to watch a video and do some homework if you're in some basic, because practice makes perfect. Practice makes perfect. All right, here we go. Example 2. Use Euler's method. Oh, snap, 5 steps. Are you serious? I'm going to get it started. It's your job to make sure you finish it on your own, okay? All right, so Euler's method, let's get it started. To get it started, I'm going to have to know what my change in my x is. How do I find my change in my x? It's b minus a all over the number of steps. Okay, so what's b and what's a? Where am I starting at? Ooh, I'm starting at x equals 2. Okay, and I want to approximate when x is equal to 1.5. So I'm going down a little bit, huh? So my b is 1.5. So I'm 1.5 minus 2 all over how many steps? Oh, snap, it wants me to take 5 steps. So what would my step size be, right, class? It'd be negative 0.1. Okay, let's get rolling. Okay, so this is probably the toughest part, remembering the table. We have an x and we have a y. Okay, remember my next guy. My next guy is y prime, or the slope, dy dx, right? And then my next guy is my change in y. What is my change in y? This one you might have to remember. It's your m, your slope, times your dx. Remember, how do we get that? Well, that's dy dx is equal to m, okay? And then what's my other one? It's my new dude. How do I get my new dude? It's my y plus my change in y, and that's the new guy. All right, let's do the first one together, and then you're off on your own. Here we go. We start at 2, 3. Okay, and then I got to find y prime. Oh, they have a x and a y in that this time. So it'd be 2 times 2 minus 3, which would be 4 minus 3, which would be 1. Okay, so that's my first slope. So then my delta y would be my slope, which is 1 times my change in x, which would be negative 0.1, which gives me an answer of negative ooh, snap. Let's do that math over here. Negative 0.1. So what is my new y? So my new y is going to be 3 plus negative 0.1, which is 2.9er. Okay, so I come back here. Okay, and what's my new x? Well, the change in x is negative 0.1, so 2 plus a negative 0.1. So I'm at 1.9, right, class? And then my y, my new y, is going to be 2.9. Now, what is your job? Your job is to see if you can finish the rest of this. And then when I unpause this guy, it's magically going to appear. See if you can get it right on your own. It's great practice. Go. Aloha, class. I almost got done, and then the computer went out. Well, so my pen doesn't work. So I always take care of you guys. So I did a little booyah. Okay, so there's your answer. Okay, obviously we're 1, 2, 3, 4, 5 steps. You all got to go all the way to 1.5. Right? And after I go all the way to 1.5, there we go. My answer would be 2.61051. I almost got all the way to it right there. I was at 1.6. The computer went out. I'll give you one more quick view. I know you could hit pause, but there you go. I hope you did it on your own. Remember, you're never supposed to round until you have a final answer, okay? I think my pen will work on this bad boy. It better, or I might go crazy. All right? All right, so let's roll that guy up. Let's see if it does. Now, remember, the AP loves to do this, okay? what is the AP going to do? What they will do is they'll give you the problem using Euler's method, and then they'll snap it on us, and they will, and they'll give us a table. You know, shame on me. Just going back to this. Oh, at least it's working. Is it working? Okay, sweet. I did want to talk about one thing. Sorry, class. We're going to go back to this guy really quickly. Okay, and this is why Euler's method was so big back in the day, and it's good for us right now, is that if you look at this, you cannot separate the variables there. So being that I can't separate it, you're like, why did we have to do 5 steps for that one? Well, I wanted to be accurate, right? Right, class? And there's no way of finding the error for this dude because we can't find the original equation, right? You can't separate the variables there. I'd like for you to try and then show me in class, all right? Big time bonus if you can. I will buy you a enjoy, yuck, yuck, all right? But here we go. Let's keep on rolling. All right, big time challenge right here at home. Be tough. Get after the challenge. How the heck would I do it? They're giving me a table right here. How the heck would I do this? How would I use Euler method? 2 steps to find an approximation of 2.6. Hit pause, try it right now. Come on, you can do it. Okay? All right, unpause it. All right, I see that table. It looks very daunting. It looks like I can't do it. So you know what I'm going to do? I'm going to make it familiar to what we did in class. And what did we do in class? We made our chart. Okay? Right? Some of us, we struggle when we see something different. But you always want to relate it to how you did it in class. All right? And if you relate it to how you did it in class, you'll probably get the right answer. Okay? All right, so let's do this. Well, first off, I probably need to know my change in my x. And my change in x is going to be b minus a all over n. So where did I start? We're trying to approximate 2.6. Oh, it says I'm starting at 3, right? That's the first thing we start with there. So I'm going to start with 3, and I'm going to end with 2.6. So that'd be 2.6 minus 3 all over 2 step sizes, which would be 2. Correct, class? Okay, that'd be my change. And if I do that, I get a negative 0.2. So that's going to be my change in my x's, which kind of makes sense because look, right? I go down 0.2 for each one of those guys. All right, should have enough to get going. So we start at 3 comma what? Oh my gosh, what's the y? Oh, sweet. Holmes, it's right there on the table, right? Boom, that's y. So it's 3 comma 2. Well, what is y prime? Y prime, oh, they gave that to me too, right? Y prime is the derivative at 3, so it's just 0.4. Well, what is my change in y? Well, change in y is probably going to be the one that you have to remember the most. And your change in y, if you ever forget, remember it's dy dx is equal to m. I'll say it again. That means dy is equal to m times your change in your x. So that would be 0.4. I'll show you the work for this one times your change in x, which was negative 0.2. I got ahead of myself. Well, what is 0.4 times negative 0.2? That would be negative 0.08, right, class? And then my new y would be 2. Add that to it, and I'm at a 1.92, right, class? So my change in x is going to be by going down 0.2, so I'm right there, and my new y is 1.92, right, class? And then we keep that process, and guess what? In that beautiful table right there, they really took away a lot of the work. For example, what the heck is y prime at 2.8? Well, y prime at 2.8 is 0.7, right? Well, all I have to do, remember then, is how do I find the change in y? And the change in y is just the slope, which is 0.7, times my change in x, which is negative 0.2, right? Which would be negative 0.14, right, class? And then how the heck do I find the new y? Well, I just take my old y, and I add my change in it, which would be negative 0.14, and I get an answer of 1.78. 1.78. Okay? And then guess what? Am I done? Well, let's go. Oh, 2.6, right? I'm going to take away 2, change in x. Oh, I have my new y. And whenever you have your change in x of what you're trying to do, we are donezo. So that's approximately equal to 1.78. Once again, we can't find an exact, right? Or we can't find an error because you can't find the exact. But there we go. Hopefully you were able to do that on your own and you were able to use a table to help yourself out. Okay? Example 4. One last one here. Actually, you know what? Your challenge right now, you're going to do that, guy. We're going to check your answer in class and see if you did it correct. Also, you are going to go into your worksheets. Okay, go into your worksheets for Euler's method, and I want you to have done before class tomorrow 1 through 8. All right, that is your homework. It's a quick 20-minute video. Go make it work and be ready to go. Maybe for a quiz in class. Aloha, Euler's method. BC, let's go.